Alrighty, my lovely algebra students. So we reviewed systems of equations. Oh, my mind just went blank. Now we're going to review systems of inequalities. Everyone's favorite. Well, at least it's my favorite. I think you all hated doing this one. But systems of inequalities are like systems of equations where it's two or more linear inequalities. Okay? So it's two or more linear inequalities. The only difference with this is the way they look. So instead of looking for where these two intersect, where the two lines intersect, we're looking for where the two shadings or solution sets intersect, okay? So I'm going to put that up here because I didn't leave myself enough room. So we are looking for where our solution sets intersect. Okay? So remember, inequalities have more than one solution to them, right? So they have what's called a solution set because they have more than one answer, more than one solution. So we are looking for where their solution sets intersect, and that is our solution to the system, okay? So before we do that, we're going to go over how to graph on a coordinate grid. So graph on coordinate grid, okay? Oh no. Okay, so our symbol, we have greater than, we have less than, we have greater than or equal to, and we have less than or equal to. So I'm going to take a second to write that down in words. This is something you do need to memorize for your regions, okay? So if you do not know this, I would make this chart right now. It will help you in the long run. Okay, good. So we know our symbols. We know what they mean in words. Now, you should remember from last year what type of circles that they have. So if I have a greater than or less than, they have the same circle type when we graphed in a number line. And that circle type was an open circle, which means that solution is not included, okay? So open circles means it's not included in our solution set. When we have greater than or equal to or less than or equal to, because of that equal to portion of it, that means that it is part of the solution set. So we use closed circles to represent that, okay? So if it does not have a greater than or equal to or less than or equal to symbol, it's open. If it does, it is closed. I always like to think it takes more ink to make this kind of symbol than it does this one. So I need more ink when I'm making it circle. That's one way I think of it, okay? Now, our line type. So our line type when we have a greater than or less than is always a dashed line, okay? Because it's not included, all right? When we have solid lines, when we graph linear equations, it's always solid because those are solutions. The things on the line to our inequalities are not solutions when these are our symbols, so we use dashed, okay? Greater than or equal to and less than or equal to are going to have solid lines because they are part of the solution, because there's that equal to, okay? And now shading, our favorite thing. When we have greater than, if this is my line, my shading is above the line, okay? So it's above. So all of my solutions are above the line. When we have less than, we have our dashed line still, and all of our solutions are below. Okay. Greater than or equal to, we have our solid line, and again, all of our solutions are above. Less than or equal to, all of our solutions are below. Okay. So this chart will help you if you memorize it, okay? It will help you, it will save you time, and it will help you gain those extra points on your regions, okay? So here's how we graph on a coordinate grid. I'm now going to give you a system, okay? So two inequalities. So here's our first one. X plus y is greater than 2. I'm going to leave some space in between. And then we have 2x minus y is greater than 1. Based on how they look right now, we cannot graph them, okay? We cannot graph them because we need our inequality to be in the form y with whatever symbol, mx plus b, okay? So we need it to be in this form with our inequality symbol there. So to do that, we need to rewrite these inequalities. So for the first one, to rewrite it, I need to simply just get rid of this x. Okay, in order to get rid of the x, I need to do my inverse operation. I need to find its opposite, so I get a 0 pair. So the opposite of positive x is negative x, so minus x. Then we do it to both sides because of the property of equality. And we get y is greater than, you could have negative x plus 2 or 2 minus x. It doesn't matter the order. Okay, commutative property. So I'm going to put a 2 minus x. All right, we can graph that, all right? Now that it's in our y mx plus b form, our slope-intercept form, okay? Now this one we need to rewrite. So it's going to take an additional step that the first one did not, okay? So we want to get rid of our 2x first. And in order to do that, we need to subtract it. So minus 2x on both sides. My 2x's cancel out, and I'm left with negative y is greater than 1 minus 2x. Now, remember, with inequalities, if you are dividing by a negative coefficient or multiplying by a negative coefficient, our inequality sign flips, okay? So our inequality sign is going to have to flip because we need to divide by negative 1. And everything on this side needs to be divided by negative 1, not just the 1, okay? So we get y, the flip of greater than is less than. 1 divided by negative 1 is negative 1. A negative divided by a negative is positive, so positive 2x. So these two right here, we can put into our calculator and we can make a table, okay? We're going to do it by hand because I can't figure out, because I'm bad at technology, how to pull up the calculator on here and do it that way, okay? So we're going to make it by hand. This is the only piece that goes into your calculators, okay? And your y equals window, okay? These are the only pieces. So we're going to make a table for the first one. So we have, this is our first inequality. Okay, so I'm just going